The next approach to calculate dispersion is a standard deviation. Standard deviation is a simple thing to understand because it is not a new approach. We are not doing anything new. We are not deriving or defining anything new. The standard deviation, simply if you have to understand, it just is a square root of the variance. What is the variance? Variance is the average of sum of all the squared deviations. Here the biggest problem is squaring the deviations. Deviations are squared. Why the deviations are being squared? In order to get rid of the negative sign. The negative sign will not be, when there is a negative sign, when there is a negative deviation, when you are trying to add the sum of the deviations, the total range will be very less, right? So you will not be able to get the entire range. You will be able to get only the confined range. That actually is not a range. I hope you got the point. When a lesser value is getting subtracted from, rather mean is getting subtracted from a lesser value, rather a higher value. I would say that mean is getting subtracted from a higher value. What will be the result? The result will be a negative value. Let us say mean is equal to 6. Let us say, just a minute, mean is equal to 6. Mean is equal to 6. One data point is 8. Okay. So you need to subtract mean from 8. 8 minus 6 is equal to 2. Here this is a positive value because this weight is on the right side of the mean. But there are some values which are to the left side of the mean. So let us say there is 4. When you take the deviation, there will be 4 minus 6 and this 6 will be subtracted from 4. Then the result will be minus 2. Okay. This minus 2 will have a negative impact. It is a negative measure of the variance. When you are taking minus 2 plus 2, the total range will be equal to 0, right? But actually total range is equal to 4. From the mean 6, one data point is at 8, one data point is at 4. Okay, so we have a range of 2, but the minus 2 and plus 2 actually are getting cancelled here. This is the biggest problem. That should tell you how widely or how closely the data points are spread across. We should be able to identify the exact range, but a negative sign is going to ruin all these things. So in order to avoid these negative signs, we are going to square them. When we square them, we will be able to get rid of the negative sign. But squaring them will give you one more problem. Here, what we are going to square? Minus 2 square is equal to 4. Plus 2 square also is equal to 4. I hope you got the point. Let me explain you clearly. So there is a data set that is 4, 6, 8. Here the mean is equal to 4, right? Now, when you take the deviation will be minus 2 and a plus 2. In order to avoid cancellation, we will square minus 2 square, we will go for minus 2 square plus 2 square. What you will get? Minus 2 square is equal to 4, plus 2 square also is equal to 4. You are going to get 8. Okay, we need to divide 3, I am not showing that, but here what is the deviation? This deviation is not an actual deviation. This deviation is a square deviation. The actual deviation is only 4, right? So what we need to do is, we just need to square root them. Here I am not showing you divided by 3 because that's a variance. In order to keep the things at the simplest level, I am just not showing you that. But this 8 is a exaggerated range. In order to reduce it, confine it to the actual range, what we do, we are going to divide, square root the total variance. What is the total variance? Variance is the sum of, the average of sum of all the square deviations. When you divide it, when you square root them, you are going to get the standard deviation. That's what all about standard deviation.